Hello and welcome to the first in our summer series, digging through this box of slides that we unearthed in the physics department. They contain a huge variety of images and photographs of the universe viewed through telescopes from all over the world and are going to be the springboard for our videos over the summer. Up first, Saturn may be one of the closest objects in the images from our slides, and it's definitely the most visually striking of the planets, thanks to its iconic ring system. But what we're going to cover today is why those rings disappeared from view this year, and what you have at most a handful of chances to view over the next couple of months until our next chance in 2040. When the solar system was forming, masses attracted to one another, forming heavier and more dense objects, which could then pull in more mass. The Sun, being the greedy goose that it is, took in the overwhelming proportion of the mass in the solar system, around 99.8%, with the remaining fraction of a percent being shared amongst planets, moons, asteroids, comets, and anything else that could pull itself together. As each mass gets larger, it might not just pull in more matter, but also cause some of that matter to begin orbiting around the heavier masses. This is how the planets fell into their orbits around the Sun, and how moons settled into orbits around the planets. But the closer you get to an object, the stronger its gravitational field becomes. This becomes stronger and stronger as you get really close to a planet or star, meaning that something orbiting really close could lead to a large difference in the grav field strength on the near and far side of a moon. At the right distance, this can provide tidal forces which will stretch and squash moons. This can give really interesting effects like the heating and cooling of tidal forces on Europa, a moon of Jupiter, which allows it to potentially have subsurface oceans of water under its icy exterior. But if you get closer than something called the Roche limit, the difference between the forces on the near and far side of a moon can actually cause it to rip apart. This is what we think happened to form the innermost rings of Saturn, where the vast majority of the mass of the rings actually is. Saturn does have some rings beyond the Roche limit, but it is thought that these come from, among other things, ejections from Enceladus, one of Saturn's many moons, not just other objects being pulled apart. As an aside, this means that some of Saturn's smaller moons have settled into orbits in the gaps between different parts of its ring system. One of them, Daphnis, was observed by the Cassini mission to be generating waves at the edge of the rings as it passed by them. I don't have time to go into this properly and cover the rest of the video, but if I remember, I'll pop the link for the article that I found this out on whilst researching the video down in the description. Fingers crossed. Much like the Earth, Saturn is tilted in its orbit about the Sun at an angle of 26.7 degrees. This is only slightly more than the tilt of Earth from its axis, so you might think that our view of Saturn doesn't vary much from our planet. What we aren't considering, though, is that both Earth and Saturn are orbiting the Sun, and due to Saturn orbiting almost 10 times further out than the Earth, they have vastly different time periods. Saturn takes 29.4 Earth years to orbit the Sun. As a result of this, sometimes we're in a position where the North Pole of Saturn is facing more towards the Sun, making the rings appear below centre. At the other end of Saturn's orbit, its south pole faces more towards the Sun, so from our perspective, the rings appear above centre. And at halfway between these 2 points, we view Saturn from side on, and because most of the rings are so thin, around 10 meters thick for the inner rings, they seem to disappear completely. This is what happened earlier this year and happens around every 15 years. But it isn't the disappearance of Saturn's rings that I want to focus on in this video. It's another thing that has/will happen 10 times during 2025 and won't happen again until 2040. Much like the Sun took the vast majority of the solar system's mass when it's formed, Titan has a very high proportion of the total mass of Saturn's moons and rings, over 96%, and is therefore the largest of Saturn's moons by a very clear margin. This also makes it the second largest moon in the entire solar system, only narrowly behind Ganymede, which orbits Jupiter, and both of which are actually larger than the planet Mercury. Titan orbits at an angle of 0.35 degrees compared to Saturn's equator at a distance of around 20 Saturn radii, meaning that for much of its orbit it is either above or below Saturn. But at Saturn's current position, Titan can pass directly between the Sun and the surface of the planet. From our perspective, we would call this a transit. From Saturn's point of view, this would be a solar eclipse. Due to the different relative sizes and distances between Saturn, Titan, and the Sun, though, Titan would take up over 4 times that angular size of the Sun in the sky from the surface of Saturn. So there'd be no chance for Saturnian astronomers to study much of the Sun's atmosphere during an eclipse. For us as an observer on Earth, these transits leave a shadow on the surface of Saturn. This is the bit that is slightly trickier. First, if you look at Saturn with the naked eye, it is just a bright dot in the sky. To see any sort of detail, you're going to need a powerful telescope, and to see the shadows of Titan passing across its surface during a transit, you'd need a telescope with at least a magnification of 200 times. Secondly, you'll need to be in the right location on Earth to observe the transits as they occur. At time of recording, there are still transits to come on the 3rd and 19th of August, 4th and 20th of September, and the 6th of October. All bar the last of these will last at least 2 hours, but will be best viewed from the Americas, as the transit occurs during the second half of their night time. For observers here in the UK, the transits would start around dawn time, meaning that the sky would be brighter than would be ideal for actually seeing Saturn in the sky, let alone being able to even observe the transits. So, unless you are one of our international viewers, thank you, who happen to already live in the right part of the world, then you're going to have to head to America to see this phenomena. Or, if you're a little bit more patient, we can always hope that the transits occur at a more favourable time to be observed wherever you are in 2040. And there we have it, the first of our summer slide series completed. Next week we'll be playing our own version of GeoGuessr, but on a universal scale to try and determine what this object is and where in the universe it is hiding. If you can't wait, consider watching another video from us, possibly this one. Please remember to like this video, subscribe to the channel if you haven't already, and until next time, please continue to watch this space. Thank you.